Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will be talking about GCSE physics resistance. We covered in the last video, by the way, if you haven't watched the last video, it's probably worth for you to watch this before getting into this. I included a link in the description below, so if you want to watch the previous video, watch it. Because in last video we covered two other major units. We covered potential difference and we covered current, as well as charge. However, last time we haven't talked about resistance. So today I made a quick video for you to cover resistance. Everything you need to know about resistance for GCSE physics. And so, without further ado, let's get started. So, what is resistance? Now, the best way to think about it is like so. I will show you. So, imagine a school corridor. So, we have a corridor like this. And we have a corridor here like this. Now, in both corridors we have the same amount. In both corridors we have the same amount of students. Say they are school corridors. In both corridors we have the same amount of people. So let's say, so roughly like so, we have this many people here, and here we also have the same amount. I know it's not exact, I'm not drawing the same amount, but imagine it's the same amount. Okay. So, these guys here, who will make it faster? Who will get through the corridor faster? Well, these guys will get through the corridor faster. They can move freely, they can move along freely, without bumping into anybody, without having any difficulties. Whereas these guys will be walking along the corridor very slowly because they are all so cramped. They are so cramped. They are all walking very slowly and they're pushing past. They're pushing their way through. They're trying to get to wherever they need to be. But they have to get there very slowly because they are so cramped. And that's a very good way to illustrate resistance. That's how resistance works. Here we have a low resistance situation, low R I'm gonna put down, and here we have a high resistance situation, and that's the best way to think about it. Only instead of corridors, here we have a wire, and instead of people we have the charge flowing. That's the difference. So in high resistance situation we have lots of charge flowing through usually a very small wire, and therefore the resistance is high. The potential difference is driving that charge through it, but the resistance is very high, and therefore they move slowly. Now, we covered that in last video. What unit governs the rate of the flow of charge? What unit essentially says how often the charge goes through a certain point? It's current. So high resistance will lead you, for the same voltage, for the same potential difference, high resistance will give us a lower current. Whereas low resistance for the same potential difference would give us higher current because these guys move faster. So the rate of the flow of charge is higher because these guys move faster. So that's how resistance works. And the reason why I explained this to you is because now the equation for resistance will make sense. The equation for resistance, one sec, I'm just gonna grab a red pen. There. The equation for resistance is like so. V equals I times R. So that is potential difference PD, which is equal to current times resistance. And that's the equation. That's the equation for resistance. And of course, the thin wire here usually would be a resistor. So, resistor on a, as I showed in the last video, basic resistor looks like this on a map, on a circuit map. Basic resistor will look like this. Now, resistors usually are a very thin wire. They usually are a very thin wire or some material that makes it difficult for the charge to flow through, therefore increasing the resistance. That's essentially what resistors usually are. Now, what is the unit for resistance? Unit for resistance are ohms, and I will show you how to write them. So, unit is ohms, like so. And ohms. So that's the basic unit for resistance. And we can use this equation with ohms and amperes and volts as our units. We can use that equation to deduce resistance by just knowing voltage and a current, or we can deduce any other element by rearranging it. We can, tell what current is if we know resistance and potential difference. We can tell what potential difference is if we know resistance and current. We can tell what resistance is if we know what potential difference is and what current is. Okay. Now, so how the resistor works. So, the resistor in a current, like I said, it's a thin wire. So, essentially, thinking back to corridors, essentially resistor is creating this situation. Like so. There we go. And say here's a light bulb that we are trying to power. Like so. The light bulb, one sec, let me just quickly color it in. There we go. So here we have a light bulb. Okay. So here's our cable. Here we have a resistor, like so. And it ends here, and we go back to our usual cable. Now, so what we have is we have charge flowing. We have charge flowing through the cable, like so. Here is flowing fast and freely. Now, it is worth noting that each cable, every cable in a circuit, will have some internal resistance, because it is essentially a limit. The internal resistance may be low, but usually those cables will have it. Now, exam questions will usually tell you to ignore internal resistance of the circuit, and that's what they mean, to ignore the inherent resistance in a cable, because each cable has it. No matter how low, the cable will have some resistance. Anyway, back to here. So here we have charge flowing nicely, and then it starts to funnel here into the thin resistor wire. And then it's very, very cramped here. So the resistance increases. Whereas current will decrease. And then it comes out here on the other side, flowing freely again. But because the charge has to work its way through the resistor here, that reduces the current. Because this is the weakest link, this is the slowest point, and no matter how fast the charge travels here, it needs to slow down here. So now, what is the point of resistors? Why on earth would you want to reduce current? Why on earth would you want to do that? Well, if we have a way too high potential difference, if we have a way too high voltage, and we want to power this little tiny light bulb, then two things can happen. Either it will shine very brightly, and then after 10 seconds the battery will go off because we just had all this charge rushing to it. Or another thing that's more likely to happen is just gonna blow. The bulb is gonna blow because we putting way too much potential difference across it. We're putting way too much current across it. That's the main issue. We're putting way too much current across it, and it just cannot handle it, and it just blows. It heats up way too much, and the little carbon wire there blows. So that's where resistance comes in. Resistance allows us to use these appliances that would normally blow because of way too high power from, say, socket, for example. We can put a resistor across the appliance, and then the current drops, and we are able to safely use that light bulb despite the 240 voltage in UK that you would get from a plug socket. And also in some more complex circuits as well, where in some parts you need a lot of current, and in some parts you need a little current, you can use the resistors to sort of drive that current in a different direction, in a direction of where you want that current to go, and have less current flowing through other parts of the circuit where you don't want it to go. Now, another thing is that resistors are not the only thing that provide resistance. Light bulbs themselves also provide resistance. So these guys here will also have resistance. Another thing that resistors can give us resistance. And another thing that can give us resistance is diode. Diode can give us also resistance. So diode was something like this. And diodes give us resistance. They give us very low resistance in one direction, and they give us very high resistance in other direction. That's how, if you remember, they control the flow of electricity. They control the direction in which electricity flows. And that's how diodes do it. Because if current wants to flow the opposite way, then it will ramp up the resistance. Whereas if it wants to flow the correct way, then the resistance will stay very low. So resistors, so cables, almost everything has an inherent resistance to it. Now, resistance in diode and light bulb will behave differently to resistance in a resistor. And we will talk about that in a following video next time. I will cover all these different factors that can affect resistance, and I will cover how resistance behaves in all these different components. But this is it for today, guys. Thank you very much for watching my videos. I really appreciate, guys, whenever you watch my videos. If you have any questions whatsoever, just shoot me a question in comments. I am more than happy to answer anything you may be confused about. I will straighten it all out for you. If you want to stay up to date on daily math, science and biomedical science videos, hit the subscribe button below. And if you like the video, if you think it helped you, give me that like button. Thank you very much again for watching, and see you next time.